Okay, and now we're on to and conversion. So there are a lot of units in physics, and they don't always agree. Like we have not scientific, the metric system, and we have the standard measuring system we use. I think it's called the imperial system that we use here, feet and inches. And we're going to have to convert between those a lot. So, for example, if I just told you I had 24 inches, and I wanted to know how many feet is that, well, you could probably tell me that's 2 feet. But to be very precise and careful here, what you're doing here is you're actually using a conversion. We know that every 12 inches equals 1 foot. And so what we're doing here is we are trying to get these inches to be feet. And so I write this conversion as a fraction. 12 inches, 1 foot. Now in actuality, this fraction here is 1, because 1 foot is 12 inches. So the same thing divided by the same thing is 1. We're not changing the value, but we are changing the units. Because if you were to think about this like algebra, if you have 2x all over 2y, the 2's would cancel, right? Same with these inches here. Now you're left with feet, and 24 times 1 would be 24 over 12. So 24 divided by 12 is 2. Now in a simple problem like this, it's probably more work to do that, to do the actual conversions like that, but it's not always going to be that easy. So for example, we have 2.3 meters. And then we ask how many inches. And here's the conversion factor. We know 39.3701 inches equals 1 meter. Okay, now, where am I getting these conversions? You will be given the conversions that you need. So if we are ever in a position on test, quiz, homework, whatever, you should be able to either use Google, like on your homework, or you should have the conversion on test or quiz. And if you don't, you should ask me because I want to give those to you. So here we go. We have 2.3 meters, and we want to switch into inches. So when I multiply by my conversion factor, we want to have the meter side be canceling. Now because meters on top and on bottom, these would cancel. And I'm going to put the conversion up here. Now we're left with inches. That's what we want. Now if I multiply with a calculator, I get an answer of 90.55123 inches. Now if you think about that, that's kind of crazy. Like, I know that I have about 2.3 meters. And when I convert it, I suddenly know that I have 90 and 5 tenths, 5 hundredths, 1 thousandths, 2 ten thousandths, 3 hundred thousandths of an inch. And there's no way that we could have been that precise if we knew we had about 2.3 meters. That's way too precise. So again, we got to do 2 sig figs. And now because that 90 would normally round to 91, with the 5, we would say we have about 91 inches using correct sig figs. So I have a try problem for you now. I want you to try this, pause the video, and then see if you can get the answer just by doing this conversion thing, this conversion with fractions. So the question is, the average lifespan is 71.0 years. That is true from Google. So that's every country, every person in the world, all averaged together. And the average beats per minute of a heart is around 80. Okay, so the question is, in the average lifespan, how many heartbeats does your heart go through? So you should pause the video, give it a try, and then come back because we'll do it in a second once you're done trying. Okay, so the thing you start with is 71 years, 71.0 years, excuse me. Now, this right here is a conversion rate. It is 80 beats every 1 minute. And so we have to turn years into days, into hours, into minutes, and then use the beats per minute. And so the 71 years, first we're going to take 1 year, and that 1 year is the same as 365 days. Now I know you have leap years, so maybe it should be 365.25, but it'll be about accurate if we just use 365. Alright, and every 1 day we have 24 hours. 1 hour is 60 minutes. And then here we use our conversion of every 1 minute we have about 80 beats. Okay, the minutes cancel, the hours cancel, the days cancel, the years cancel. We are left with beats here. All we have to do is multiply and divide. And now because there's nothing on the bottom of our fraction here, all we're going to do is multiply. There's no division here. So we take our calculator, times 24, times 60, times 80. We would get 29854080000 beats. Now let's do some adjustment here. I had 3 sig figs, so I would round to about 299 and then replace these with zeros. 1, 2, 3, 4, 5, 6, 7. And then I would also change this into scientific notation. So if I do 2.99, that'd be moving the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd be times 10 to the 9th. That's how many beats in the average lifetime. So it's approximately, if I put a comma there, and there, and there, thousands, millions, billions. It's about 3 billion beats in the average lifespan. Okay, that doesn't seem like that much when you think about it, but that is quite a bit. Alright, and now we have to talk about 2 more things along with units. We have to make sure that we have, for the metric system, the correct prefixes, and then we'll talk about 2-dimensional and 3-dimensional dimensional conversions too. So metric is based on tens always. So for example, if this was meters and I had 10 meters, then this would be called a decameter. If I had 10 times that, 10 of the 10 meters, we would have 100 here. This is called a hectometer. And then if I have 10 times that, it would be 1,000 meters. 1,000 meters is a kilometer. Now this is most often used. I don't see people using deca or hecta almost ever, but it's good to know. And then if you go the opposite, if you have 1/10 of a meter, that is called a decimeter, which, by the way, decimal is from the same prefix, so that's how I remember it. Deci means a tenth. If you do 1/10 of a tenth, that's 100, so that'd be centi. And then if you do 1,000, that would be milli. So millimeter, centimeter are often used. Meter and kilometer are used. Now if I change this all to grams or liters, we would have the same prefixes for the same meanings. The reason metric is so convenient is because it goes along with scientific notation. It's always timesing or dividing by 10. And so we will be using those quite often. Now the last thing here, we have to talk about 2D and 3D dimensions, dimensional conversions. So for example, So a cube has dimensions 2.3 by 7.1 by 8.2 inches. The question is, how many cubic feet are in that cube? Okay. Well, the first thing we should do is find the volume of that cube. And the volume of the cube is when you multiply length times width times height. And so we're going to work with 133.906 inches cubed. So if you had little cubic inches, you could put about 134 of them in the cube that we have here. Now, it's not as easy as dividing by 12 though, because this is volume. If we were to go aside here and think of a foot cubed, that is my foot by foot by foot example. That would be 12 inches by 12 inches by 12 inches. And so 1 cubic foot is actually equal to 12 times 12 times 12, which is 1728 inches cubed. So I had to, and I do this most often, I don't just have these numbers memorized, I just do this every time I need it. If I have to figure out conversions between volumes, I picture, if I want cubic feet, I picture 1 cubic feet is 12 by 12 by 12 inches, and then I figure out, well, 1 cubic foot then is this. And so we use that conversion now to figure out how many cubic feet it is. So we take 133.906 inches cubed, we multiply by our conversion, and we're going to put 1728 inches cubed on the bottom because we want our inches cubed to cancel, and what it's equivalent to on top. And so we're going to take 133.906 and divide by 728. What we end up with is 0.077491898. Now, in the original problem, the least sig figs we had was 2. It was just always 2. So we're going to include 2 significant figures. We would say that this is 0.077 feet cubed. Okay. So now I'm going to have you try this. This is your try problem. Let's say we had a painting that was 1.7 meters by 2.1 meters. The question is, how many square centimeters? Okay, you should pause the video and try the same kind of strategy we had to figure this guy out. Alright, so 1 square meter has 100 centimeters by 100 centimeters. So 1 meter squared has the same as 10,000 centimeters squared. So that'll be the conversion that we use later. Now if I do 1.7 times 2.1, we get 3.57. And that's in meters. And so we will use the 1 meter squared, sorry, that's meter squared, and we will use the 1 meter squared and put 10,000 centimeters squared up there. The meters cancel, and we will end up with 3.57 times 10,000, which is going to be 35,700. But we got to adjust it just once more because we only have 2 sig figs here. That is the least accuracy we have. So I got to round this to be, it's around 36,000 centimeters squared. It's a lot of centimeters squared.